Okay, so an inscribed sphere inside a cube. So as you can see here, there's the cube with the inside sphere. And if you join the corners from one point to the other point using straight line or 45 degree centigrade, that will give you the point of contact. This will also give you the point of contact that the sphere touches the face of the cube. Okay, so point of contact. Okay, so first thing we need to do then is, this cube is easy for us to find the center because we just join the diagonals using the 45 degree set square. Okay, where they intersect or cross each other, it's going to give us the center. Okay, once we have the center, we'll bring a line down here. That point there is going to be our radius. So we get our distance from the center to the edge. Double check now you have it perfect. Just touch it on the edge. So inscribe the sphere. Okay, so there's one inscribed. Next thing we need to do then is we can bring down the center line. Okay, say join the diagonals again over here and over here. That will give us our new center point. Once we have the center point, we can use that. Our radius should be the exact same because it's a cube, all the faces are the same. Just swing our sphere, our radius. Okay. Next thing we do then, we can bring everything down 45 degrees. Bring across our center point. So we have our center point in two views. Let's find it in the third view. So just bring it across. Hits the 45 degree line, bring it up. Bring it across. And that's going to be our center point. So we have our radius still on this. If we are correct, it should hit our line in the right place. Okay, so here's a point of contact. It's POC. POC, point of contact. Point of contact. Okay, same point of contact. Okay, so you're going to have point of contact on every single face for an inscribed sphere. Next thing we need to do then is circumscribe it. So circumscribe it is we're putting the sphere around the cube. Okay, and we can see here that our cube touches the sphere in every corner or every apex of the sphere will touch the point of contact on the sphere. Okay, and then we've one at the back as well. Okay, this isn't as easy to do, so we have to follow our procedures. We need to get a true length. So by joining the diagonal, use the brown marker here. By joining the diagonal from one corner to the other, like so, and there are other diagonals from one corner to the opposite corner of the cube, where they intersect each other, okay, is going to be the center point. So the first thing we do, in plan, we will draw in that diagonal, so it just looks like a line in plan. So in elevation, our line looks like this. Okay, so we have to look in here 90 degrees because we need the true length of this line. So we look in 90 degrees to it, and we're going to project out here. I'm going to project the end out here. We're going to set up a new x1, y1 line. Okay. It's x1, y1. Make sure now that this is 90 degrees. Here and here, 90 degrees. And then we will project our height. So we have to take our height over here from our elevation. All heights are always taken from elevation. Once we get our height, we're going to step it up on this line. There's our height. Okay, once we have that height, we join it back. So from there to there is actually a true length. Okay, so we have our true length line. So we also need to project up our center point. Okay, if we do, it won't give us a true point. So we need to bisect this line to find the center. The center of this will give us the radius of our circumscribed sphere. So we bisect it. From there to there now will give us our radius. Okay, so we're going to take that radius. Okay, and because they share the same center point, we can use that center point to circumscribe in the elevation and circumscribe it in our end view. Okay, so in all our views it looks like our corners are not touching.